I can definitely say that quote applies to me. But can Schrödinger's cat help us out? Well, the answer to that in just a moment. First, I want to mention that my next video is going to be on what alien life might look like in this solar system. So if that's a topic that interests you, don't forget to hit the notification bell after subscribing to make sure you know exactly when that video comes out. Also, if you have a question or a topic for that video that you want me to explore, don't forget to leave it as a comment below and I'll do my best to incorporate it in the video. Now that that's out of the way, let's do some quantum mechanics. Let's start with the fact that Schrödinger's cat is a thought experiment designed to teach us something about quantum mechanics. So imagine this, we have a cat placed inside a box. We can't see inside this box unless we open it, but there's also plenty of air so the cat won't suffocate. Now, also inside this box we place a single radioactive atom. Attached to this atom is a Geiger counter that will trigger if the atom decays. Also attached to the Geiger counter is a vial of poison. If the counter goes off, the vial of poison is broken and the cat is killed. So what we do is we wait the exact half-life of this atom, so there is a 50% chance that it's decayed and has broken our vial of poison. So, what's happened to the cat? Well, I need to explain a couple of things before we get there. States and observations are key parts of this thought experiment. A state simply describes something about our system, and here we have a system with two states, dead and alive. In a system with multiple states, they are all simultaneously true until we make an observation. So for the cat, until we open the box and have a look inside, it's both dead and alive. In quantum mechanics, an observation is needed to figure out what state we're in. It's hard to define, but basically anything that interacts with our system can count as an observer. Also, an observation, once made, will remove the quantum mechanical nature of our experiment. So when we do open the box, there's a 50% chance we'll find the cat alive, and a 50% chance that we will not. However, there is a problem with this setup. The Geiger counter alone would be an observer, so it would remove the quantum mechanical nature from this setup, and so the cat would be either alive or dead and not both. But does this make the experiment useless? Well, not really. The main point of Schrödinger's cat is to show how unintuitive quantum mechanics is when we try and apply it to a macro scale. In a way, Schrödinger's cat doesn't need to make sense. So I guess you can say it's both right and wrong. See what I did there? Yeah? I'll let myself out. So, why doesn't quantum mechanics make sense? Well, basically because we didn't evolve to understand it. Our brains evolved to comprehend things on the scale of our everyday experiences. We didn't need to understand quantum mechanics to find food or avoid predators, so we didn't evolve to. I mean, even Newton's laws of motion, whilst understandable, are still fairly unintuitive. And the same goes at the other end of the spectrum on the big scale. General relativity too, likewise, is hard to comprehend because our brains didn't evolve to. In these cases, we must rely on a mathematical understanding, and although this might be unsatisfying to many, it's still really powerful, and we shouldn't underestimate how well we can understand the world with the tools we've got, even if it's all a bit weird. Remember, I'm almost a doctor, and don't forget to leave a comment below of what you want to see in my next video. And until next time, be like a proton. Stay positive. Standard. Our brains evolved to comprehend.